I had him dead to rights and nothing to shoot him with. That's how one F-4 Phantom crew member described the moment everything the Air Force believed about modern air combat fell apart. 1966, somewhere over North Vietnam, an F-4 Phantom, the most expensive, most advanced fighter-interceptor in the American inventory, found itself turning with a MiG-17 at close range. The MiG-17. A subsonic Korean War design with a crude gunsight and 3 cannons bolted into its nose. The Phantom carried Sparrow and Sidewinder missiles, radar that could track targets dozens of miles out, 2 seats so one man could fly and another could fight. Pentagon planners had designed it to kill Soviet bombers at standoff range before the enemy ever knew an American aircraft occupied the same sky. So, what happened when that same Phantom ended up 500 yards behind a turning MiG, deep inside the minimum range of every missile it carried? Nothing happened. The crew sat there, throttle forward, watching a kill they couldn't take. The MiG-17 had guns. The Phantom did not. And that single fact, that the most powerful fighter on Earth carried no weapon capable of killing another airplane at close range, became the defining scandal of American air combat in Vietnam. The theory had sounded airtight. Missiles had rendered the dogfight obsolete. Robert McNamara's Defense Department ran the numbers, built the models, and concluded that future air engagements would happen at ranges measured in miles, not yards. The F-4 reflected that conviction down to its bones. No internal cannon, no gun port, not even a mounting point where one could go. Grumman and McDonnell Douglas engineers built the airframe around missile bays and radar systems. If you're watching this and you've served on a flight line, crewed a Phantom, or studied this era until your eyes bled, drop what you know in the comments. Hit subscribe and like so other people who care about getting this history right can find this channel. The stories that matter most are the ones somebody actually lived. Back to the problem. The Sparrow missile needed several seconds of continuous radar lock to guide itself to a target. The Sidewinder needed an infrared signature, a hot exhaust pipe, ideally viewed from behind. Both missiles had minimum engagement ranges. Below roughly 1,000 feet of separation, neither weapon could arm itself, track properly, or maneuver hard enough to connect. The physics didn't care about doctrine. A missile needs distance to work. A cannon needs proximity. Vietnam provided proximity in abundance, and the Pentagon had designed its premier fighter for the other thing entirely. Why did engagements keep collapsing to knife fight range? The answer involves rules of engagement, weather, and the specific geography of Route Package 6, the most heavily defended airspace on the planet at that time. American pilots operating over Hanoi had to visually identify their targets before firing. Cold War-era identification friend or foe systems couldn't reliably distinguish a MiG-21 from a friendly F-105 at distance. So, the beyond visual range kill that justified the Phantom's entire weapons philosophy became, in practice, illegal. Crews had to close the distance, confirm the target with their own eyes, and only then engage. By that point, they'd blown through optimal Sparrow range and often found themselves merging with enemy fighters at speeds and distances where a 23mm cannon would do just fine, if they'd had one. The after-action reports from Rolling Thunder missions in 66 and 67 read like a repeating nightmare. Missile after missile fired inside parameters that the weapons were never designed to handle. Miss rates ran catastrophic. The Air Force's own internal assessments used that word. Catastrophic, their word. MiG-17 pilots, North Vietnamese, and their Soviet advisors figured this out faster than anyone in Washington wanted to admit. American fighters broke off when engagements went close, and the Phantoms never strafed. Two facts that became obvious after a handful of engagements. A MiG-17 driver who survived the merge and got inside minimum missile range had functionally disarmed a 40,000-pound interceptor carrying 8 air-to-air missiles. The Vietnamese adapted their tactics accordingly. Get close, stay close, force the Americans into a turning fight where all those missiles became dead weight. The kill-to-loss ratio told the story. During the early Rolling Thunder period, American fighters achieved barely a 2-to-1 exchange rate against enemy aircraft. In Korea, American pilots flying F-86 Sabres with guns had managed better than 10-1 against MiG-15s. Something had gone profoundly wrong. St. Louis, Missouri, 1958. Inside the McDonnell aircraft plant, engineers finalized the airframe that would become the F-4 Phantom, and not one of them drew a gun into the design. The omission didn't happen by accident or oversight. It followed direct orders rooted in a theory that had been gaining momentum across the Navy and Air Force for nearly a decade. A theory that said the era of close-range air combat had ended permanently. The roots ran back to fleet defense. The Navy needed an interceptor that could protect carrier battle groups from Soviet bombers carrying nuclear-tipped cruise missiles. The engagement scenario looked nothing like a dogfight. Enemy Tu-16 Badgers would approach at medium altitude in predictable formations, launching their missiles from 50 miles out or more. The interceptor's job involved racing to meet them, acquiring targets on radar at maximum range, firing semi-active radar homing missiles, and turning back before ever seeing the bomber with naked eyes. Speed mattered. Radar range mattered. Missile reliability mattered. A cannon, in this specific tactical problem, contributed exactly nothing. The Navy wrote its requirement accordingly, and McDonnell built the airplane to match. "We designed it to kill bombers," one McDonnell engineer later told an interviewer. "Nobody asked us about MiGs." So, why did the Air Force buy the same airplane for a fundamentally different mission? That question gets at something uncomfortable about how the American military made procurement decisions during the McNamara years. Robert McNamara arrived at the Pentagon in 1961 with a mandate to eliminate waste and duplication across the services. His systems analysts, the so-called whiz kids, looked at the Navy's Phantom and saw an airframe that could serve both branches. One airplane, one production line. Massive savings. The Air Force brass resisted initially. They wanted their own dedicated air superiority fighter. McNamara overruled them. The F-4 became a joint program, and the Navy's Fleet Defense Interceptor became the Air Force's primary fighter for a war that hadn't started yet. What got lost in the transfer was the Navy's mission assumptions, which came along with the hardware. The gun was gone, and so was any close-range contingency, along with any acknowledgement that an Air Force fighter sweeping enemy airspace over hostile territory might encounter tactical conditions radically different from a carrier battle group defending open ocean. The whiz kids ran cost-benefit analyses on everything from missile reliability to maintenance hours per flight. They did not, apparently, run an analysis on what happens when rules of engagement force your missile fighter inside its own weapons envelope. That's not sarcasm. It's a gap in the analytical record that nobody has adequately explained. The studies that justified eliminating the gun assumed permissive firing rules that Vietnam's political reality never allowed. The Air Force's Tactical Air Command raised objections. Fighter pilots who'd flown in Korea argued for an internal gun. General officers who'd earned their rank in piston-engine dogfights wrote memos. The file on these internal debates stays partially classified, but enough has surfaced to confirm that dissent existed and lost. McNamara's office responded with data, missile probability of kill figures generated under test conditions that bore little resemblance to combat over Hanoi. The probability of kill for a Sparrow missile in controlled testing hovered around 70%. Over Vietnam, actual Sparrow performance fell below 10. The gap between those two numbers killed American airmen. 10%, that number should have ended careers. Out of every 10 Sparrow missiles fired in combat over North Vietnam, 9 missed. Not 9 out of 10 fired at extreme range or in poor conditions, 9 out of 10, period, across all engagements where American crews pulled the trigger believing they had a valid shot. The Sidewinder performed marginally better. Roughly 15% of AIM-9 Sidewinders found their targets. 1 in 7. For a weapon the Pentagon had staked the entire air-to-air mission on, 15% qualified as the good news. How did the gap between test range and combat grow so grotesque? The answer breaks into 3 problems, each compounding the others until the entire missile-dependent philosophy collapsed under its own assumptions. First, the Sparrow. The AIM-7 required the launching aircraft to maintain continuous radar illumination of the target from the moment of firing until the moment of impact. The Phantom's AN/APQ-72 radar had to paint the target with a focused beam, and the missile rode that reflected energy all the way in. In a sterile test environment, blue sky, cooperative target drone flying straight and level, no electronic jamming, the system worked beautifully. Over Route Package 6, nothing cooperated. MiG pilots turned hard the instant they saw a Phantom's nose track toward them. A 4G brake turn at close range could walk the target out of the radar beam in under 2 seconds. The Phantom crew then faced a choice: follow the MiG through the turn to maintain lock, bleeding energy, losing situational awareness, becoming vulnerable to a wingman they hadn't seen, or break lock and waste the missile. Most crews broke lock. The ones who didn't sometimes died chasing a radar solution while a second MiG closed from behind. "Your head's down in the scope, trying to keep the strobe centered," one weapons systems officer recalled years later. "And your pilot is screaming about a MiG at 7 o'clock. You can't do both." The Sparrow demanded a cooperative target in a war where no target cooperated. Second, the Sidewinder. The AIM-9B model carried an uncooled lead sulfide seeker head that tracked infrared radiation, essentially heat. It worked best when fired from directly behind the target, where the jet exhaust pipe presented a clear thermal signature. The seeker's field of view spanned roughly 4 degrees. Fire it from any significant angle off the tail, and the seeker struggled to distinguish a MiG's exhaust from sun-heated clouds, warm ground returns, or the afternoon sky itself. Vietnam's tropical climate made this worse. Ground temperatures in the Red River Delta routinely exceeded 100 degrees Fahrenheit, and humid air scattered infrared energy in ways that the missile's simple seeker couldn't filter. Sidewinders launched at low altitude over the Delta locked onto rice paddies, river reflections, anything radiating heat. The missile had no friend or foe logic. It chased the strongest source. Third, and this mattered more than either missile's individual shortcomings, the engagement geometry that Vietnam's rules of engagement forced onto American crews negated whatever theoretical capability the weapons possessed. Both the Sparrow and Sidewinder carried minimum range limits. The Sparrow needed approximately 4,500 feet of separation to arm its warhead and establish a guidance track. The Sidewinder needed roughly 1,000 feet. Below those thresholds, the missiles either failed to arm or couldn't maneuver sharply enough to reach a crossing target. But the visual identification requirement meant American pilots routinely closed inside those minimums before they could positively confirm an enemy aircraft and clear themselves to fire. By the time a crew had eyeballed a MiG, called it hostile, and selected a weapon, they'd blown through the Sparrow's effective envelope and sat right at the ragged edge of Sidewinder range. The dead zone between minimum missile range and zero distance, where a gun would have dominated, belonged to nobody. The Phantom owned that airspace with nothing to shoot. Maintenance compounded everything. Sparrow missiles sat on wing stations exposed to tropical heat, monsoon rain, salt air aboard carriers, and the constant vibration of catapult launches. The AIM-7's electronics used vacuum tubes. Moisture corroded connections. Thermal cycling cracked solder joints. Squadrons reported that 30 to 40% of their Sparrow inventory tested as degraded or non-functional before ever leaving the rail. The missile that hit 10% in combat had already been pre-filtered. Those were the rounds that actually fired and guided at all. The true reliability number, counting missiles that refused to launch or went ballistic off the rail, sat somewhere lower. The maintenance logs from Ubon and Udorn air bases in Thailand tell a grim, repetitive story. Sources conflict on exact figures by squadron and by month, but the trend never varied. 14 American aircraft lost in air-to-air combat during 1966. North Vietnamese pilots studied every one of those engagements, and a pattern screamed back at them from the wreckage. Colonel Thun, the North Vietnamese ace Nguyen Van Bai, described it bluntly in a post-war interview. "We noticed they never fired when close, never." The realization spread through the Vietnamese People's Air Force faster than any tactical bulletin could travel. American Phantoms carried no gun. The most dangerous fighter in the sky had a blind spot you could exploit by simply getting near it. MiG-17 pilots at Kep and Gia Lam airfields began training specifically for the merge, that chaotic moment when opposing fighters pass each other head-on and the fight collapses into a swirling, low-speed brawl. They practiced closing to gun range and staying there. What did that look like from the cockpit of a MiG-17? The roar of the Klimov engine at full military power, a sound like tearing sheet metal. The stick shaking under 4 and 5 Gs in a sustained turn. A MiG-17 could pull into a turn radius roughly half what a Phantom could manage at comparable speeds. Tighter, slower, nose always tracking. The Vietnamese pilots didn't need radar. They needed eyes, nerve, about 300 yards of separation, and nothing else. Their ground controllers helped close the distance. Soviet-trained GCI operators, ground-controlled intercept, vectored MiG flights to approach American strike packages from below and behind, using terrain masking along the karst ridgelines northwest of Hanoi. The MiGs climbed into the Phantom formations already inside Sparrow range. By the time American crews spotted them, the fight had already entered the dead zone. They came up through the undercast like they knew exactly where we'd be, one Phantom pilot from the 489th Tactical Fighter Squadron told a debriefer. Because they did. The tactical refinement accelerated through 67. MiG-21 pilots adopted a different approach, slash attacks using their speed advantage. A MiG-21 would dive through an American formation at Mach 1.4, fire its atoll missiles on the way through, and extend away before Phantom crews could react. But the MiG-17 drivers embraced the knife fight. They wanted the merge. They wanted the turning contest where a lighter airframe and a tighter turn radius let twin 23mm cannons do the work. This was one of the sharpest tactical adaptations of the entire war. A nominally inferior Air Force identified a structural weakness in the world's best fighter and built an entire combat doctrine around exploiting it within months, not years. The Americans, meanwhile, kept flying the same airplane with the same empty gun bay. The Su-16 pod rattled so hard on the centerline station that pilots at Da Nang called it the washing machine. 20 pounds of vibration-damping material packed around a 6-barrel M61 Vulcan cannon, the whole assembly hanging off a pylon designed for bombs. It weighed 1,750 pounds loaded. That drag penalty alone cost the Phantom roughly 80 knots in top speed and turned its already punishing fuel consumption into something closer to hemorrhaging. Why strap a gun to the outside of an airplane built to never need one? Because men kept dying in the dead zone. The pods arrived in theater during 1967. Two variants, the Su-16 with a ram air turbine that used airflow to spin the barrels, and the Su-23 with an internal electric drive. The Su-16 needed forward airspeed to function, which meant it couldn't fire during hard maneuvering when the airflow disrupted. Pull 4 Gs in a brake turn exactly when a pilot needed the gun most, and the barrels slowed, jammed, or quit entirely. You'd squeeze the trigger and hear this dying whine, said Captain John Kirk, who flew F-4Cs out of Ubon in '67, like a lawnmower running out of gas. The Su-23 solved the spin problem, but introduced new ones. Its electric motor drew power from the aircraft's generators, competing with radar and fire control systems for electrical load. And neither pod solved the fundamental accuracy issue. An internal gun sits on the aircraft's centerline, rigidly mounted bore-sighted to the gunsight. A pod hangs on a pylon. It flexes. The vibration of 20mm rounds firing at 6,000 rounds per minute shook the pod against its mounting hardware, walking rounds across the sky in patterns that had little relationship to where the pipper sat. Dispersion at 300 yards spread roughly 4 times wider than an internally mounted weapon. Captain Kirk flew 37 missions carrying the Su-23. He fired it in combat twice, hit nothing either time. On May 20th, 1967, an F-4C crewed by Major James Hargrove and First Lieutenant Eric Salge took a MiG-17's cannon fire through the left intake, during a turning fight 60 miles northwest of Hanoi. Hargrove had a gun pod. The after-action report notes he fired 112 rounds before the pod jammed. Salge's voice on the emergency frequency came through, broken by static and engine noise, then stopped at 2:14 p.m. Their Phantom hit the karst ridge below Thud Ridge at 400 knots. Hargrove had the gun. 112 rounds fired, a jammed pod, and a karst ridge at 400 knots. "Give us a gun or stop sending us up there." That line appeared in a letter from a Phantom pilot at Ubon to his congressman in the summer of 1967. The congressman's name isn't in the declassified file. The pilot's name is redacted. But the letter reached the Armed Services Committee, and it landed alongside a stack of after-action reports telling the same story in colder language. McDonnell Douglas had already started work. The contract for the F-4E variant, Echo, came through in August of '66, driven by a requirement that read, in the dry cadence of Pentagon procurement, an internally mounted high-rate-of-fire weapon system suitable for air-to-air engagement at minimum range. That's bureaucracy's way of admitting men had died for a mistake. The engineering challenge looked simple on paper. Put an M61A1 Vulcan cannon inside the nose of an airplane whose nose already contained a radar dish, a fire control computer, an infrared sensor, and miles of waveguide. The nose had to get longer. 7 inches of additional fuselage stretched the F-4E's snout forward, and the radar dish shrank from a 32-inch to a smaller unit to make room. Below and slightly aft of the radome, the gun nestled into the airframe like it had always belonged there. 6 barrels, 6,000 rounds per minute, 639 rounds in the drum, 11 seconds of trigger time before the ammunition ran dry, which sounds brief until you consider that a 1-second burst put 100 rounds downrange in a cone tight enough to shred a MiG's wing root at 300 yards. The Vulcan's installation point sat almost exactly on the aircraft's centerline. No flex, no pylon harmonics, no washing machine vibration walking rounds into empty sky. The gun's rotary mechanism ran off an internal hydraulic drive independent of the aircraft's electrical system. The SUU H-23's power drain problem gone. Bore sighting aligned the weapon to a new lead computing optical sight that tracked target motion and calculated deflection angles automatically. A pilot put the pipper on a MiG, and the sight told him where to aim ahead of the target so the bullets arrived at the same point in space at the same time as the airplane. For a generation of fighter crews trained on missiles that missed 90% of the time, the simplicity felt almost obscene. The first F-4Es rolled off the St. Louis production line in June of 1968. The E model restored something more important than hardware, a psychological dimension that missiles had stolen. A Phantom carrying Sparrows fought from a distance, dependent on electronics, vulnerable to any degradation in the guidance chain. A Phantom with an internal gun could close to knife fighting range and stay there. The dead zone vanished. Every piece of sky between 0 and 1,000 feet, the airspace where MiG-17 pilots had built their entire tactical doctrine, now belonged to the Phantom again. The math changed overnight. A MiG driver who turned hard into a gunless F-4C forced the American to either break off or watch helplessly. A MiG driver who turned hard into an F-4E with a Vulcan cannon heard 20mm shells punching through aluminum before he completed the turn. Colonel Robin Olds had gone home by then. He'd fought the entire air war over Hanoi in '66 and '67 with F-4Cs and Ds, scoring 4 kills with missiles through sheer tactical brilliance and aggression, dragging his Phantom into positions where even a 10% weapon could connect. "If I'd had a gun," he told an interviewer in 1984, "I'd have been an ace 3 times over." I believe him. His gun camera footage from Operation Bolo alone shows half a dozen tracking solutions inside 200 yards where he had nothing to fire. The F-4E arrived in Southeast Asia with the 366th Tactical Fighter Wing at Da Nang in November of '68. The timing coincided with the bombing halt over North Vietnam, which meant the Echo wouldn't see sustained air-to-air combat until linebacker operations in '72. When it finally did, the results spoke in a language the Pentagon couldn't misinterpret. For a F-4E cruise claimed multiple MiG kills with the Vulcan during Linebacker 1 and 2, including engagements where missiles had already failed and the gun provided the only remaining option. Steve Ritchie became the Air Force's first ace of the Vietnam War flying an F-4D with missiles. But the crews who flew the E felt something different strapped to that longer nose. 639 rounds of certainty. The sound of the Vulcan firing through the airframe registered not as a buzz or a rattle, but as a deep, tearing vibration that pilots felt in their spines before they heard it in their helmets. Grumman's engineers at Bethpage were already mounting an M61A1 into the F-14 Tomcat's left fuselage before the first F-4E gun kills over Hanoi had been confirmed. The Navy had watched the same disaster unfold from carrier decks in the Tonkin Gulf, and the Tomcat's design team never considered leaving the cannon out. 676 rounds. Internal mount. Non-negotiable. So, why did every subsequent American fighter follow the same pattern? Because a generation of fighter pilots who'd survived Vietnam moved into procurement offices and test squadrons and program management billets throughout the 70s, and they carried the dead zone with them like scar tissue. Colonel John Boyd, the maverick tactician who'd already reshaped air combat theory with his energy maneuverability work, pushed the internal gun requirement into the F-15 Eagle specification with what one program office member called religious intensity. Boyd's briefing slides from 1969 included a single line that read, "A fighter without a gun is a fighter without options." The F-15 got its gun, so did the F-16, a 511-round M61 mounted in the left wing root, feeding from a drum so close to the cockpit that pilots could feel the ammunition weight shift during hard turns. The F/A-18 Hornet followed suit. The requirement appeared in every tactical fighter specification the Air Force and Navy issued from 1968 forward. What changed in the doctrine manuals? The phrase minimum range engagement capability entered formal requirements language and never left. Air Force Manual 51-1, revised in 1973, restored close-range maneuvering combat to the fighter pilot curriculum after nearly a decade of treating it as obsolete. The Navy had already stood up its fighter weapons school, Top Gun, at Miramar in 1969, built specifically to train crews in the visual range knife fight that missiles couldn't win alone. The F-22 Raptor carries an M61A2. The F-35 Lightning carries a 4-barrel GAU-22. 60 years after McNamara's Pentagon declared the gun dead, Lockheed Martin still machines a cannon port into every airframe. The after-action studies that drove these changes sit in filing cabinets at the Air Force Historical Research Agency, Maxwell Air Force Base, Alabama. Project Red Baron, the classified analysis of air-to-air engagements over Vietnam, compiled 3 volumes between 1967 and 1974. Volume 1 covers 65 through 68. The original classification, Secret NOFORN. Portions remain redacted. The study cataloged every American air-to-air engagement, every missile fired, every kill and every miss, sorted by weapon type, range bracket, and engagement geometry. Its assessment of Sparrow reliability in combat conditions uses the word unacceptable, the study's own language, printed plainly in the findings. The declassified portions of Red Baron carry the file designation K23 9.04722253, shelved in the Albert F. Simpson Historical Research Center collection. The binding is standard government-issue gray cardboard. Inside the front cover of Volume 1, someone taped a black and white photograph, an F-4C on the ramp at Ubon. Tail number 64669, centerline SUU, 23 pod, hanging beneath the fuselage. The pod's barrel housing shows scorch marks from a jam. The photograph carries no caption and no date.